This week on the show, we have OpenZFS-kmod port available. There is an article out using blacklistd with npf as fail-to-ban replacement. A ZFS raidz expansion alpha preview 1 is available that you could look at. There's a little rant here about audio VU meter increasing CO2 footprint for you, which is not good. There's XSAVE and Compat32 kernel work for LLDB under NetBSD. And we ask where are the icons for modern X applications are coming from in this week's episode of BSD Now. BSD Now, episode 303, OpenZFS in ports, recorded on the 19th of June 2019. Hello, I'm your host, Benedikt Kreuschling.
And I'm Alan Jude.
And we have exciting news in the headlines this week because the ZFS on FreeBSD port has been renamed to OpenZFS.
Yes, so the ZFS on FreeBSD project, which is the effort to basically take the newer upstream OpenZFS repo, that's currently called ZFS on Linux, and port all those features back to FreeBSD. As we've talked about before, because there's not a shared history, porting one feature at a time proved to be too problematic. And so the effort was undertaken to just reuse all the existing Open Solaris compat code and basically just report ZFS to FreeBSD very quickly using all the shims that are already in place. And as part of this, we will then upstream the FreeBSD specific bits under, ifdef FreeBSD or whatever, to that repo. And eventually, once that's done, the ZFS on Linux repo will actually be renamed to OpenZFS.
Which is what it is, yeah, the actual origin.
Last week, in the ports tree, you could experiment with this new version of ZFS by installing the ZOL package and the ZOL-kmod package. But those packages have now been renamed OpenZFS and OpenZFS-kmod. And importantly, the actual kernel module is now called OpenZFS.ko, so that you can specify which one you want to load. Previously, when they were both called ZFS.ko, obviously KLD load would default to loading the one in the kernel rather than the one in your modules directory. By renaming the other one to OpenZFS, it's now easy to specify which one you want to load at boot.
Oh yeah, that allows more flexibility.
Yes, and one of the nice things with the updated version, that basically after the rename to OpenZFS-kmod, that kernel module has had the ioctls renumbered to be compatible with the original ZFS in FreeBSD. So it means that you'll be able to continue using the ZFS and zpool commands that are built into FreeBSD, even when you're talking to the new kernel module, whereas before they were not compatible. Now they are. Obviously, if you're using the original command line tools, you won't have access to the new features of those command line tools, like zpool iostat has a latency mode and so on, but you'd only get that by using the new zpool command. But to help with the transition, you, instead of getting an error, if you use the wrong zpool command, you will actually get the output. So they're compatible now. And so then if you have both the ZFS that's part of base and the ZFS from ports installed, you can just, in your loader.conf, specify ZFS_load equals yes to load the original ZFS, or OpenZFS_load equals yes to load the OpenZFS module.
Very cool.
Currently, sadly, the kmod for FreeBSD still requires FreeBSD 12 stable or 13 current, because the newer crypto support that was required to support ZFS native encryption was only merged into 12 after 12.0. And so it's not available in 12.0. I'm looking at if there's a way around that. I have a basic idea that might work, and if it doesn't, then I have a second idea, and if that doesn't work, it probably just isn't possible. But I'm going to see if it's possible to make it so you can add this on top of stock FreeBSD 12 to make it a little easier for people to test. But if you grab a 12 or 13 snapshot from the official FreeBSD website, you can just install the package now. Whereas before, you had to build world on 12 or 13 with ZFS disabled and all this other stuff. But this way, you'll be able to test by just installing the kernel modules on a 12 or 13 snapshot. And when 12.1 comes out, it will just work.
That's cool. And the port actually allows more frequent update and waiting for the next release to come around.
Yes, which will be important when we're bug fixing as we're trying to get this ready to become the new base version.
Mm-hmm.
So then we're also looking at how to make the user lands coexist. So currently you end up with two ZFS commands, sbin ZFS and user local sbin ZFS. And your path environment variable probably searches the base system first, which makes sense. So we thought about naming the ones that come from the port, like ZFS.new or something. Or maybe we could call it actually OpenZFS as the command, although that might be slightly weird. Because OpenZpool doesn't make sense as a command.
No.
Maybe OZFS and OZpool or ZFS.new or something like that, so that you can easily specify which one you mean. Which kind of leads into my other idea is that maybe for future versions of FreeBSD that are going to support both, we make sbin ZFS and sbin zpool a switcher script that either looks for ZFS and zpool where they're put away like /libexec or whatever, or use the ports version and have some way to easily switch back and forth, or have it just auto detect. If I have the port installed, I want to use the new one, and if I don't, I want to use the old one. Or maybe it could actually detect which kernel module you have loaded and automatically grab the userland tool that matches the kernel module you're running, which might make sense.
Oh, that would be great.
So yeah, you have that as some options. But anyway, if anybody has ideas or feedback on that, we'd love to hear it so that we can make the experience of being able to test this stuff as easy as possible, because that's basically what it needs now, is a lot of testing. For testing purposes, if you just load the new kernel module and import your pool, it should be fine. As long as you don't run the zpool upgrade command, you'll still always be able to import the pool back on the original FreeBSD 12 version of ZFS. But if you run the upgrade command, then it'll only be usable on newer ZFS. So don't do that.
And don't use it for production workloads yet. So this is still experimental, more or less.
It's getting there though.
Yeah, okay, but just a warning.
It's not unsafe, but yes, it is possible to panic it, and you don't want to do that. For extra safety, you could also use a zpool checkpoint. So we talked about checkpoints a little bit on the show before, but basically they're basically a whole pool snapshot that covers everything. Because a regular snapshot doesn't help you if you delete the snapshot in the dataset.
Of course, yeah.
With a zpool checkpoint, you can undo zpool upgrade, ZFS destroy, renaming stuff will get undone, all that. Basically what it does is stops freeing from happening. So as you know, ZFS is copy on write. So every time you write something, or every time you change something, it gets written to a new location. While a checkpoint exists, we never overwrite a location. Basically, we never actually get rid of any data. And so you can always go back to how the pool was, when you created the checkpoint.
At that point in time.
The downside to that is that, you will eventually run out of space. So be careful there. But a checkpoint would allow you to create the checkpoint under FreeBSD 12 or whatever, boot into the newer version of FreeBSD and the new OpenZFS-kmod, try it out, do a bunch of stuff, and then if it somehow messes up your pool, which I don't think it can really, you'll be able to roll back to the checkpoint. But be warned that rolling back to the checkpoint will erase any changes you've made since the checkpoint. So if you've saved any new files, they will be gone.
That's the trade-off, yeah.
So be careful of that. But the checkpoint is a nice way to be able to always go back on the pool. But you can only have one checkpoint at a time, and while a checkpoint exists, you will never free any space, so you will run out of space eventually. So they're not really meant to be kept forever, but they're great for this kind of testing use case or for undoing an upgrade.
Okay, yeah. Then test. As many things that are found are fixed or can be fixed. If they aren't detected, then people have to run with those, and we won't want to have that later on.
If you find something, open a bug report on github.com/ZFS on FreeBSD.
Okay, good to know. And I will definitely try this out. Next up, we have a how-to, how to use blacklistd with NPF, the NetBSD's PF version, as a fail-to-ban replacement. And this is part of a NetBSD desktop tips series on the same blog over at unitedbsd.com. And they talk about blacklistd, BlacklistBSD provides an API that can be used by network daemons to communicate with a packet filter via a daemon to enforce opening and closing ports dynamically based on policy. The interface to the packet filter is in libexec blacklistd-helper. This is currently designed for NPF. And the configuration file, which is inspired from inetd, is in etc blacklistd.conf. Now, blacklistd will require the BPF JIT, just-in-time compiler for the Berkeley packet filter, in order to properly work. And in addition to that, naturally, NPF, of course, as a front end, and syslogd as a backend to print the diagnostic messages. Remember also that NPF shall rely on the NPF log virtual network interface to provide the logging for TCP dump to use. In the actual article, there are all the examples and steps that you need to do to activate and write your first rule set. So notice here that, unfortunately, don't ask the author why, in 8.1, which came out, we covered last week, NetBSD 8.1, all the required kernel components are still not compiled by default in the generic kernel, though they are in head, so the next release version will have that, and are rather provided as modules. So to enable NPF and blacklistd services, you would normally result having them in being loaded automatically, but predictably on secure level equals 1, this is not going to happen, because then you can't load modules anymore. And while we were speaking of blacklistd, I was at a hackathon in Vienna over the weekend, and so that was the weekend before this one, and I worked on a chapter, or as a part of the PF chapter in the FreeBSD handbook, also adding blacklistd instructions to it so that people can use it with FreeBSD's PF version. It's not finished yet. It's out for review so that people can look at it. And so eventually FreeBSD will also have instructions how to run blacklistd, which was imported from NetBSD a couple of years ago. But it's a nice article, quite straightforward, into the rule set and how to write your first blacklistd rules, as well as showing the actual offenders, the hosts or the IP addresses that got blocked already. Next up, we also have something interesting, a work in progress for the raidz expansion, Alpha Preview 1.
Yes, so this is a pull request over on the ZFS on Linux GitHub, and it's the work Matt Ahrens has been doing to bring, partly sponsored by the FreeBSD Foundation, to bring raidz expansion. So this would allow you to take, say, a raidz 2 of 6 disks and add a 7th disk and then an 8th disk, and basically widen a raidz rather than having to add a whole second raidz to grow the pool as you do today. So this is, I think the number 2 most requested feature in ZFS. Now, this is just alpha quality, and there's still a bunch of work to be done, but it would be helpful to get people to start playing with this a little bit too. To that end, I wonder about actually pulling this into the ZFS on FreeBSD branch and making a test ISO that people could play with there. But anyway, worth checking out. Currently, what is implemented is you can expand a raidz device by just doing zpool attach pool name, your raidz, and then the new disk. There's a simple test script to run during the test suite. Currently, the way it works is it basically reflows all your data, kind of like it was text in a paragraph in your Word editor or text editor, and you just widen the page width, and it just kind of reflows the paragraph to make it fit the screen. So all allocated space on the device is rewritten and therefore copied to its new location on the raidz VDEF. The reflow happens in the background over the course of multiple transaction groups, which is an improvement. The previous alpha on FreeBSD did it all as one transaction and meant basically the machine was useless until it finished the whole reflow, which could take a very long time.
Yeah, okay.
So the new code also handles reads and writes that happen during the reflow to make sure they happen correctly. You can also reboot or export and import, so you can interrupt the reflow and resume it later. If you're at the very, very beginning, it might start over from scratch, but in general, you'll be able to resume if you need to interrupt it. And if you run zpool status, it will give you a progress report so you can have an idea of how far it is and how fast it's going. After expansion is complete, you can initiate an additional expansion. So like I said, if you have 6, you can go to 7 and then to 8, one at a time, but you this way don't have to... it's not like you can only grow once. You can keep growing repeatedly. All the additional space becomes available as soon as the expansion is complete. Device failure or silent damage is automatically handled. So, if data doesn't pass the checksum when it's being read before the expansion, it'll resolve that before finishing the reflow so that it doesn't make that error permanent. It's interruptible, so you can reboot and export import as required. And the status, including the completion time, will be reported in zpool status after it's done. Things that are not done yet is adding the on-disk feature flag. Obviously, once this feature exists, there'll have to be a flag to tell older versions that, hey, you need to understand how this works before you try to read this pool. It says progress should be reported in terms of offset on disk, not number of bytes copied. So basically, it should tell you how far through the VDEV it is rather than how many bytes it's copied.
That's more interesting as a number or as a statistic.
The logical stripe width does not increase. So any data that was backed up before doesn't actually get widened, or any data written before doesn't get widened as part of the reflow. And I think currently, as a not finished feature, this doesn't actually change the logical stripe width for all new writes yet. It still writes the old ones the bad way, the older way as well. Currently, if you crash at the very beginning of a reflow, you could actually crash the pool, so that's not good.
Well, this is an alpha.
Yeah, it's an alpha. Currently, you must have a healthy pool when you start the reflow, so you can't do a reflow with missing disks at all. It doesn't yet use the SIMD instructions for the raidz math, so it doesn't have the acceleration of the FPU there. And it's missing documentation and all the automated testing. Also, big scary note, this feature should only be used on test pools. The pool will eventually need to be destroyed because the on-disk format is not compatible with what's going to be the final release.
Okay.
Because there's a couple more changes that have to happen still. Additionally, there are currently bugs in the raidz expansion that can cause data loss occasionally. So yeah, don't try this in production yet.
Yeah, testers only.
Yeah, and Matt would especially appreciate if anyone has the time to write some automated tests of this raidz expansion work into the ZFS test suite, including converting the existing raid expand test shell script that he's written into a proper test case. And note that this is sponsored by the FreeBSD Foundation.
All right, yeah, good luck, Matt, for the final stages in making it production ready. And then we look forward to using it. Next up, we have kind of a rant here. Running audio VU meter increases my CO2 footprint. This is over at Medium from Martin Krakauer. He writes, I have seen some bugs in my life, even produced some good ones. But this one, people?
WTF, people.
Yeah.
So there's a graphic here on the page where he's drawn a big green arrow pointing to the VU meter in his audio program here, and it says causes 1.2 tons of CO2 emissions.
So how does this go? So a couple months ago, he noticed that the monitor on his workstation never powered off anymore. Screensaver would go on, but DPMS, to do the power off, never kicked in. So he grovels the output of various tools that displayed DPMS settings, which as usual in Xorg were useless. Everybody said DPMS is on with a timeout. He even wrote his own C program to use every available xlib API call and even the Xscreensaver library calls. Should make it available, actually. But so, no good. Everybody says that DPMS is on, enabled, and set on a timeout. Didn't matter whether I let Xscreensaver do the job or just the X11 server. So after a while, he noticed that DPMS actually worked between starting his X11 server and starting all the other clients. He has a minimal xinit-rc and starts the actual session from a script, and that is how he could notice it. While he used the regular desktop login, he wouldn't have noticed. A server state bug was much more likely than a client bug.
So basically, if he logged in but didn't start all of his stuff, the screen did power off correctly. It's important to note that he has 3 monitors that together consume over 200 watts. And so he figures he used about 700 kilowatt hours just from the monitors. And then, you have to consider air conditioning on top of that and all this other stuff that would have happened. So definitely, 2,000 plus pounds of extra CO2 because of this bug.
Ah, that's bad. Okay, so let's be a bit more greener here. The actual bug he recently had time to debug, so he did a binary search on all the X11 clients that his session contains to see which one would disable DPMS when started. He had a feeling that this is somehow related to how everything now plugs into dbus and maybe generates events that way. That wouldn't explain why his screensaver would activate, but DPMS would not. So it turns out that the meter bridge program that he runs his music through is the culprit. It is a pretty regular VU meter connecting to Jack D. WTF? How can that be? Again, he suspected some dbus interaction since somebody needlessly hacked up the Debian install of Jack D to interact with dbus. And a million things there are trying to go through some other idiotic sound transport indirection. You can even make endless loops of the emulation layers in Debian sound. Oh, that doesn't sound good. He then did the binary search of the source code of MeterBridge to see which section of code would trigger the bug. The problem appeared when it entered the SDL event loop. Initializing SDL was all fine, just the loop was not. Wait, SDL? Why does VU meter need SDL? Well, it's just as convenient a way to get texture display in a window. They didn't know how harebrained SDL's decision making is. So yeah, the question goes, why does SDL disable my screensaver by default? And the answer here is many applications using SDL are games or screensavers or media players where the user is either watching something for an extended period of time or using joystick input, which generally does not prevent the screensaver from kicking in. Of course, you can disable this behavior by setting the environment variable SDL_video__ allow screensaver equals 1. This can be set globally for the user or a per application basis in the code. And then he asks, further, how brain dead is this exactly? And goes into more details of SDL's implementation here.
Yeah, they say that, even assuming you actually want to disable the screensaver, they managed to screw that up. The screensaver still comes up and blanks the screen with this SDL code. It just doesn't power the monitor off. In SDL versions of reality, DPMS was also unconditionally disabled when the program was running at all. Otherwise, obviously, games and video players are expected to reactivate the screensaver while you pause the game or the video. I mean, come on. I have paused videos on my desktop right now. Did that decision maker here even use a computer? So basically saying that people who write games and video players who have a legitimate need to disable the screensaver already know to manually disable the screensaver. That's what they have to do the same for, the DirectX APIs for Windows and so on. Existing software already has calls to do this for all the other APIs. So the fact that SDL has that by default is actually more of a pain because they have to invert the call of and decide to reactivate the screensaver when the video is paused instead of the other way.
There's a point there.
Yeah, and so finally, an environment variable is a really bad way to deal with this. The problem is that variables persist as programs fork and exec, and you can easily end up invoking this option for another process where you didn't intend to. Of course, in this specific situation, it's fine since nobody ever wants to turn their screensaver off entirely. And it doesn't even work in the first place.
Yeah, so there goes the CO2 into the air.
Yeah, SDL's got its defaults backwards.
Yeah, so someone should look into this and fixing that. Next, we have XSAVE and Compat32 kernel work for LLDB. This is over at NetBSD's blog, continuing their series of making LLDB work more closely for the operating system. So Upstream describes LLDB as a next-generation high-performance debugger. It is built on top of LLVM Clang toolchain and features great integration with it. At the moment, it primarily supports debugging C, C++, and Object-C code, and there is interest in extending it to more languages. So that's as the background. In February, the author of the blog here has started working on LLDB as contracted by the NetBSD Foundation, so they sponsored that work. So far, he's been working on re-enabling continuous integration, squashing bugs, improving NetBSD core file support, and lately extending NetBSD's ptrace interface to cover more register types. And there's more details in the April 2019 report on that. And in May, he was primarily continuing to work on new ptrace interfaces. Besides that, he's found and fixed a bug in ptrace Compat 32 code, pushed LLVM buildbot to green status, so that's good to have, and found some upstream LLVM regressions. It really goes into details of the actual implementation of LLDB and the LLVM.
And then next up, we have a post again from Chris Seiberman over at the University of Toronto. He says, some things about where icons for modern X applications come from. If you have a traditional window manager like FVWM, one of the things it can do is iconify X windows so that they turn into icons on the root window, which would often be called the desktop. Even modern desktop environments that don't iconify programs to the root window may have user program icons for running programs on their dock or taskbar. If your window manager or desktop environment can do this, you might reasonably wonder where those icons come from by default. Although I don't know how it was done in the early days of X, the modern standard for this is part of the Extended Window Manager hints, or EWMH. Applications give the window manager a number of possible icons, generally in different sizes, as ARGB bitmaps instead of, say, an SVG. So that gives you red, green, blue, and alpha, so you can be transparent. The window manager or desktop environment can then pick whatever icon size it likes best, take into account things like the display resolution and so on, and display it however it wants, in its original size or scaled up or down, etc. How this is communicated in specifics is thought through the only good inter-process communication method that X supplies, namely X properties. In this specific case of icons, the netWM icon property is what is used, and XProp can display the size information and an ASCII art summary of what each icon looks like. It's also possible to use some additional magic to read out the raw data from the netWM icon in a useful format. For example, here, the Stack Overflow question and answer. One reason to extract all the different icon sizes for a program is if you want to force your window manager to use a different size of icon than the default. Another is if you want to reuse the icon for another program, again, often through the window manager settings. So X programs themselves have to get the data they want to put into that netWM icon property. Some programs may have explicit PNGs or similar on the file system that they read when they start, and thus that you can too, but others often build this into the program binary or compiled data files, which means that you have to go to the source code to pull the files out, and they may not be in the right bitmap format. As a concrete example, as far as I know, Firefox official icon are the default nn.png files, with nn is the size, in the browser/branding/official directory. Actual builds may not use all of these sizes that are available, or at least not put them into the netWM icon. On Fedora 29, for example, the official Fedora Firefox 66 only offers up to the 32 by 32 icon, which is tragically small on my high DPI monitor. None of this is necessarily how a modern integrated desktop like GNOME 2 or KDE handles icons for their own programs. These are generally toolkit-specific protocols that get involved, and I expect there are more support and encouragement for SVG icons so they can be, one size scales to whatever. And he says, P.S. all of this is going to change drastically with Wayland, since we obviously won't have X properties anymore. And he says, this whole exploration was prompted by a recent question in the FVWM mailing list, and mostly I think because he wanted a higher resolution icon for Firefox when it was minimized.
Yeah, those don't look too well.
Yeah, 32 by 32 on a 4K screen probably looks awfully small or scales up awfully badly.
Yeah, so maybe someone is bringing up a better icon in the future. Okay, time for the Beastie Bits this week. We have recent security innovations over at Undeadly, which means this is from OpenBSD. And so they have added some recent security innovations that were previously unreported. So the first one is a new flag called map_conceal for mmap and the allocations it does. And the second is no syscalls from pages where prot_write is still enabled. Okay, so here's the first one, the mmap of map conceal, written by Scott Solecheloa. And there's the actual commit message listed here. So map concealed memory is not written to disk in the event of a core dump. It may grow other qualities in the future. So that was a requirement by librsSL apparently, probably useful elsewhere too.
Right. The idea that, flag your secret keys so that it doesn't get dumped during a crash.
Yeah, so people who would be able to get to the crash dump would be able to get to the secret.
Yeah, basically, so you don't accidentally write that secret data out to disk.
And then Otto Murbeek added malloc conceal, introducing malloc conceal and calloc conceal, similar to their counterparts, but return memory in pages marked by map conceal, and on free 0 is actually called.
That's interesting. You allocate the memory specifically that way. You get the advantage of it not going in the crash dump, and you don't have to call explicit B0 on the free. You can just, when you free it, it automatically gets 0. That's a neat API. I like that.
And also, Theodorat was busy. He committed an improvement to check the permissions on the memory from which system calls come, and make sure that they are not in a piece of memory which is writable at the time of the call, in addition to the existing checking of validity of the stack pointer.
Yeah, so it makes sure that you never do the syscall from memory that could be changed.
That's nice. Even more security coming into OpenBSD. Very, very cool. Next up, we have an old Unix books picture and Solaris there. It's difficult, of course, to describe here.
Yep, there's a box copy of Solaris, Operating Systems by Bacon and Harris, Linux Unleashed. There's another book, the title's not on the spine, it's only on the front so you can't see. And then lastly, Harnessing Green IT, Principles and Concepts.
By the IEEE Computer Society.
Oh, they got more in-depth pictures with the front and back of each book. Yes, the blank one is Lecture Notes on C and Unix Programming from the Department of Computing and Mathematics in Australia. So that one's probably full of Unixy goodness.
Oh, yeah, for sure. 1993. And those are big tomes, so it takes some time to go through those. Okay, and then next we have a Pro Desktop, a tiling desktop environment for you. That is over at bitcanon.net.
Yep, I've been thinking about graphical shells recently. One of the great things about open source desktops is the plethora to choose from when it comes to graphical shells. However, they seem to fall into one of two camps. Either full-featured desktop environments that stick to the conventional stacking window metaphor, or narrowly featured window managers based environments that include tools like tiling window managers and often optimized for efficient keyboard use. I'm currently using the second of these, using the Awesome Window Manager. I'm really enjoying the keyboard-centric operation and almost never need to manually position newly spawned windows. Each workspace or desktop has its own layout, which describes how windows are laid out. For example, my most commonly used layout has one master window that takes up half the screen, and additional windows are stacked on the right half of the screen. The split between the two halves of the screen is easily adjusted using Super H or Super L. Layouts can be changed on the fly using Super Space to suit your different work. It says another aspect I enjoy about Awesome is its snappiness. This is largely due to the lack of any animations. Switching workspaces is instant without any unnecessary flourishes. It seems that the animation used in many graphical shells these days tend to reduce the perceived performance of the system. And they have an example of, look how much faster an iPhone is if you turn the animations off.
Yeah, you never know how much battery you might save this way.
He says the drawback to window manager-based environments instead of full desktop environments is they give up the cohesive, full-featured nature of a desktop environment. For example, these are features of GNOME that I had to research, install, and configure manually to get an awesome compositor, volume and brightness buttons or icons, network status and control, SSH agent, PGP agent, Polkit agent, a screenshotting tool, media controls, notifications, high DPI support, auto mounting of external drives, automatic multi-monitor support, screen locking, power management, battery status, low battery warnings, clipboard preservation, color management, etc., etc. Even with many of these implemented, the components don't always work as nicely as GNOME did on my XPS 15 with his built-in 4K monitor, and an additional 4K monitor externally connected. Also, when Dunst shows a notification on the built-in display, the text is sized wrong. When it comes on the external display, it's correct, even though the displays have the same resolution. On the flip side, Awesome has advantages, like the lower resource usage, mostly RAM, alternative window management styles, including stacking, titling, floating, maximize full screen, and more, is much more keyboard-oriented instead of mouse, especially on a laptop where you only have a trackpad or whatever. That can save a lot of time. And it's just better use of your screen space since you have no title bars on Windows and the top bar is very short and can instantly toggle on and off with Super B. So looking at a pro desktop, macOS is the popular choice for developers in some circles and has a cohesive, fully featured experience that you mentioned before. I conducted an informal survey on Twitter to see what things Mac users are adding to the system to make it work better. And they say the responses almost all included one or more of these elements, including better window management via the keyboard, keyboard remapping, automation, application launching, and system stats. It's interesting. It definitely used to be something I dedicated like a whole, the rightmost inch of my screen was to system status. But nowadays, I don't ever look at how busy my CPU is unless I'm having a problem, and then I start top or whatever.
Then you immediately see it.
Yeah, but I don't have an always on my screen display of how busy my CPU is or how much memory I have free. I mostly just don't care anymore. And then so he also talks about why he doesn't just use something like KDE and so on. And then he's got some screenshots comparing KDE Neon with all its icons and buttons, and then comparing it to GNOME with no buttons or to XFCE and so on. So he says he might stick with Awesome because it's working for me, but it doesn't feel a bit like I'm back in the dark ages, needing to find and configure things. So interesting.
Next up then, we have the tar pipe, which is used as an example to demonstrate all the interesting things that Unix provides in one little command. So it starts with an opening a subshell, cd source. So
I have a bone to pick with this. You don't need a subshell to do this. Tar has the capital C flag, which makes it chdir before it does its work. So if you just do tar dash capital C source dash space dash CF dash to make it write the output to dash and then do the current directory, and then pipe tar capital C destination dash XPF or whatever, it will do all this without needing the subshelling.
Okay, that's certainly true. I think it's less about the actual commands that are doing something about just by explaining what Unix can do, like subshells, the tar command, the pipe, moving the data around, and then reading from the pipe, as well as the context switches between them, and then at the end the exhausted pipe. So that's what the article is about, and not doing anything productive here or anything clever too much. But yeah, it's a good introduction to people who are new to the shell and what it can do. Pipes and subshells are definitely something people should be aware of. And last but not least, we have at least one Vim trick you might not know. So there's a good collection of Vim tricks for even the seasoned Vim people. There might be something in there. So it's a big list of things that people could use, like miscellaneous normal commands, for example. For example, I always mistype if I want to quit out of my VI session. I don't type :Q, but I type instead Q:, because my fingers are probably too quick. And then something happens. It opens a history of your previous commands. And that kind of confused me for a while until I understood what it is. And so that's described here, as well as macros, or the visual mode of VI is also, or Vim is explained. Some operators, how to move around in visual mode. Some X commands here, which are the stuff you write from the command modes, such as :s. And beyond substitution, there are a lot of other useful ways to use X. And there are a couple of examples there. There's also the exobrain Vim, where you can just fork outside of the editor for a while and then do something there. As well as some settings that are good for your vimrc. For example, like set lazy redraw. Do not redraw the screen in the middle of a macro. Makes them complete faster. So a little bit of tuning here and there. Status line output, that's also interesting to have. And of course, maps. You can map a lot of things here. And this is just scratching the surface. Auto commands are also as described, so there is something for everyone. And then plugins at the end, that's going even deeper. So yeah, have a look at that. That's certainly something that might improve your Vim food. Okay, it's time for the feedback and questions this week. Always send us your questions and feedback, or anything that is bothering you about the BSD world, or anything in particular BSD related. Send all of this to feedback@bsdnow.tv, and then in the future episode it will be covered. The first one that we have here is Johnny, another Johnny from last week, I remember. Goes like this. Hey guys, check this out. A PDP-11 running BSD 2.11 over at catbird.raidz.co.uk. There's also a PIDP-11 if you would like to emulate a PDP-11. It runs the SimH emulation software that you can find in the FreeBSD ports tree. I've never ran this software, but I just found it interesting. For the PIDP-11, you can go to another website that he linked. Anyway, love the show and can't wait for the next episode. Thanks, Johnny, for those links. That's certainly an interesting looking project here.
Mm-hmm.
Oh, here, the nostalgics are already excited.
Yes, I was, listening to some of the stuff Warner's been working on for his talk at EuroBSDCon about 40 years.
Oh, for sure. There's plenty of stuff for the people who have actually seen those in the first place running, or even owned one if they had that money. So yeah, thanks for those links. That's certainly interesting to see that FreeBSD runs on that, even in an older version. Then the next question comes from Brian with a couple of questions he has, but not too long. He writes, since you keep asking for questions, see, he replied, that's good. Thank you, Brian. What's the current state of Linux binary compatibility in the various BSDs? Looking over the official documentation, it appears that NetBSD ships userland from SUSE 13.1, which got end-of-lifed at 2017. And FreeBSD is using CentOS 6.9 userland. And of course, OpenBSD ripped it out completely. Is there a limit on the kernel compatibility, or would these work fine if I dropped in a newer userland?
Right, so in FreeBSD, there is already a port for a CentOS 7 userland, which works. Now, the kernel that FreeBSD emulates is 2.6.32, and it's missing a couple of the syscalls to go much newer than that. Depending on the application, it might work fine. Otherwise, it's not.
That's the important. It's not just dropping in a userland, it's also requiring the testing and seeing if it actually works like on the original Linux distribution. Okay, the second question is, also, is there a good reference for creating a ZFS pool that's portable across as many systems as possible? FreeBSD, NetBSD, ZFS on Linux, which is now OpenZFS, and maybe OpenIndiana. I know this will get a lot simpler once that combination, or the combined resources there, assuming that NetBSD gets included.
Well, it won't necessarily make a difference. Like, if you want to use an older version of FreeBSD and have the pool work, then you're still going to have the problem. Like, even today, you have the problem. If you create a pool on FreeBSD 12, you can't import it on 11.2.
Yeah, so he likes to make a universal pool sooner rather than later.
Yeah. So, the OpenZFS leadership group has been working on this issue. We're hoping to basically allow you, when you do zpool create, currently the default is all the feature flags are on. We might lax that a little bit. And you can specify individual features as on or off, but it's kind of annoying. I think in particular, you can basically do them all off and turn them on manually, or just have them all on. We're looking at having some aliases. So you can just say, feature compat equals OpenZFS 2019. And that will be a macro that basically turns on any feature that was supported at all the versions as of January 1st of 2019.
Okay. Yeah.
Now, that leads to some questions. When we say FreeBSD supports this feature, does that mean it's supported by every supported version of FreeBSD, or at least just the newest? Right. So if a feature is supported in 12.0 and not 11.2 or 11.3, should it go on the list or not? Probably not, but we don't want to end up too far behind either. And then, we have to figure out how to align that with things like Ubuntu starting to ship ZFS now. If they have a long-term support version they support for 4 years, we don't want to keep features behind by 4 years, but we do want it to be easy to create a compatible one. So still trying to figure out exactly what that'll look like, but we are trying to make that easier. You can kind of cheat if there's a version flag when you do zpool create. If you set the version to 28, which is the last version before OpenZFS, and then run the zpool upgrade on the oldest of the machines you need to support, it'll only have the features needed there. Or, like I said, you can do v28 and manually turn on just the features you care about.
Yeah, that should be the most compatible option. All right. Thanks for those questions, and have a good trip on your commutes. Last but not least is Mark with a ZFS question. Here we go. Hi from Philadelphia, he writes. Hello, sending greetings your way. I really enjoy the show. Thank you. We enjoy doing it. I have dabbled with FreeBSD since 2005 or so on various machines and keep going back to it. Right now, I have FreeBSD running on one of my daily use laptops. Excellent. I have a couple of questions about ZFS for you. What advantage would ZFS on a laptop with a single drive have? Okay, so first part to answer that. Boot environments, snapshots, checksumming, compression, bunch of things. So compression. Default install of FreeBSD compresses about 2:1, meaning it takes half as much disk space as the files would take on any other file system because you're getting compression. Snapshots, being able to snapshot the system and roll back is really useful. Extending that to boot environments, being able to create a boot environment, basically a clone of your root directory, before you install an update means that you can always undo the update. Or even just roll back just the operating system to the older version without rolling back your home directory, which is really nice. The other biggest thing is just because it combines the volume manager and the file system together, instead of partitioning, if your laptop has a 250 gig SSD or a 500 gig SSD, currently you would partition that into this is for the OS, this is for the home directories, this is for that, and this is the other thing. But what if you run out of space in one of those partitions and you have all the other space in this other partition? It gets really annoying. ZFS prevents that by just having all of the file systems you have can take from the free space that's available. So all of the space is available to all of the users or all of the file systems. In case you're doing something risky, always do a snapshot or a boot environment even, and you're safe and can roll back to before that. So he's thinking about the ability to sync home and working directories using snapshots and also using it for cross-OS file systems. Yeah, that's another thing. So my laptop here that I use for going to conferences, I do all my work on my development server at home, which is a big 40-core machine. But when I go to a conference, I snapshot my working directory, send it all over to my laptop, and take that with me. And when I get home, I can just send it back. Works great. Also means that I can have a backup of my laptop. If I get some really important patch finished at the conference, I can do an incremental snapshot, which is only going to be a couple hundred kilobytes or whatever, send it over the Wi-Fi back to my house, and now if the laptop gets beer spilt on it or something, all of my work is still safe. More like apple juice, but yeah, I get the idea.
Well, it wouldn't be me spilling it. Somebody else would spill on my laptop.
Yeah, exactly, yeah. Yeah, so that's the safety net.
I'm a responsible adult.
Or he lists the example of using the same home partition for BSD on OS 10 and Linux.
In my Mac, even, I have half the drive partition is ZFS for that. And yes, now that ZFS is available on Illumos, FreeBSD, NetBSD, Linux, Windows, OS 10, etc., it works great to have cross OS external drive or home directory or whatever.
Yeah, the one unifying file system for all of them. On this same theme, he writes, if one were to add a second disk drive to the laptop, would it make sense to have one disk larger than the other to house root partitions of OSs that don't easily boot to ZFS? Like disk 1 would be operating system partitions for booting operating systems not easily booted from ZFS, and the home partition for the user data, and on the second disk then, the home partition mirror.
So I was basically forced into that. In the small laptop I have, there isn't room for a second full-size NVMe, but you can get these tiny ones that are like the size of a Wi-Fi modem that you can put in the Wi-Fi modem PCIe slot. So I bought one of those, but it's only 256 gigs, whereas my main OS one is 512. But what I did is basically resize the Windows partition that came on the laptop down, and kept that in case I, once a year, I sometimes need Windows on the road to connect to a customer's VPN or something. So then I could then mirror the whole pool with FreeBSD and my home directory and everything to the smaller disk. And so, yes, you could do the same thing where you have the partitions for like your Linux and Windows or whatever on the first half of the built-in drive. Then the second drive would be a mirror of your FreeBSD pool, which you would still be able to import to get your home directory on your Linux and your other OS. So yes, that's a perfectly valid way to do it. Of course, if you can fit it, you might as well just get two big drives.
Yes.
But yes, in my case, I couldn't get a drive big enough that was physically small enough to fit in my laptop. So I did exactly what you described to fit, to mirror my ZFS, but I don't care if the Windows partition goes away someday.
Yeah, especially for laptops that have a limited extensibility, that might be a good option.
Yeah, if you get something a little bigger than, the 12.9 inch or whatever that I have, then you can usually fit two disks in it. This one, basically, I'm giving up a 3G modem, which I'm not going to get anyway, for that second bit of storage space.
Not so important then, disk space. All right. Yeah. Thank you, Mark, for those questions. And that pretty much wraps up our episode for this week. Again, if you have anything for us as an article that you found that's interesting to the show, or any questions that you have, send that to feedback@bsdnow.tv, and then we'll cover it in a future episode. Thank you for listening.